The morning sky over the French coastline near Dieppe was still breaking into daylight when Major Donald Blakesley found himself suspended at 20,000 feet, his leather-gloved hand gripping the control stick of his Republic P-47 Thunderbolt with increasing tension. The date was April 15th, 1943, and after what felt like endless weeks of training missions that went nowhere and mechanical headaches that seemed to plague every new aircraft coming out of Republic's factories, the 4th Fighter Group was finally about to engage actual enemy aircraft. British pilots stationed at the same airfields had taken to calling these massive American fighters 7-ton milk bottles, and the nickname wasn't exactly delivered with affection or respect. But all that mockery was about to become irrelevant. Through the optical gun sight mounted in front of his face, Blakesley tracked a German fighter that had just broken through the cloud layer below his position. The aircraft was a Focke-Wulf 190 belonging to Jagdgeschwader 26 Schlagerte, one of the Luftwaffe's most experienced units operating in the Western Theatre. Blakesley had no way of knowing in that moment that he was about to etch his name into aviation history books. When the range closed to 300 yards, he pressed down on the firing button. What happened next was something no German pilot had ever experienced in the skies over Europe. 8 separate Browning ANM 250 caliber machine guns opened fire simultaneously, each weapon cycling at 800 rounds per minute. The combined theoretical rate of fire reached 6,400 rounds per minute, creating a concentration of firepower that transformed the air between the two aircraft into a stream of armor-piercing incendiary ammunition. The Focke-Wulf 190, which represented the pride of German aviation engineering with its 220mm MG 151/20 cannons and a pair of 7.92mm MG 17 machine guns, simply came apart under the onslaught. Metal skin peeled away, structural members shattered, and within seconds the German fighter ceased to exist as a coherent aircraft. This single moment marked the P-47's first aerial victory and signalled the beginning of a fundamental shift in how air combat would be conducted for the remainder of the war. The story of how American fighters came to dominate European skies actually began months before that historic first kill. Back on March 10, 1943, the 4th Fighter Group had launched what was officially their first operational mission, a fighter sweep over occupied France. Radio equipment failures had plagued that initial sortie so badly that the entire formation had been forced to return to base, leading to the installation of British radio sets in the American aircraft. Throughout the early months of 1943, the pilots of the 4th Fighter Group, men who had previously flown as the RAF's Eagle squadrons before transferring to American service, struggled mightily with the transition from the nimble, responsive Spitfires they knew intimately to the absolutely massive P-47 Thunderbolts they now flew. The weight difference alone was staggering and hard to comprehend for pilots accustomed to lighter aircraft. A P-47 Thunderbolt weighed 12,731 pounds when empty of fuel and ammunition. Fully loaded for combat operations, that figure climbed to 17,500 pounds. This was more than double the weight of a Messerschmitt Bf 109G, the standard German fighter that had dominated European skies since the war's beginning. Meanwhile, at Republic Aviation's massive factory complex in Farmingdale, New York, production of these giant fighters was reaching rates that would have seemed impossible just a few years earlier. By April of 1943, the Farmingdale facility was completing one finished P-47 Thunderbolt every 4 hours, with monthly production numbers climbing steadily. Alexander Kartveli, the Georgian-born chief designer who had conceptualized the Thunderbolt, had approached fighter aircraft design with a philosophy that seemed completely absurd to European engineers who had spent years refining their craft around minimizing weight and maximizing efficiency. Kartveli's approach was simple and brutal in its directness. Maximum firepower would be delivered through maximum available power. Where German designers agonized over saving individual grams of weight, shaving fractions of ounces from components, Kartveli simply added more guns, more ammunition, and more armor plate. The resulting aircraft defied conventional wisdom about what a single-engine fighter should be. Colonel Hubert Zemke, who commanded the 56th Fighter Group, understood the American design philosophy in a way that many traditionally trained aviators did not. His unit had arrived in England during January of 1943, and by April they were actively flying combat missions over occupied Europe. The 56th would go on to become the only 8th Air Force fighter group to fly P-47 Thunderbolts exclusively throughout the entire European war, never transitioning to other aircraft types, and by war's end they would claim 674 aerial victories, making them the highest-scoring American fighter group in the theatre. The mathematics underlying the P-47's firepower were straightforward enough that even non-technical personnel could grasp the implications. The early P-47C and P-47D model variants carried 350 rounds of ammunition for each of their 8 guns, creating a total ammunition load of 2,800 rounds. The 8 guns were arranged symmetrically, with 4 mounted in each wing, and they were harmonized to create a convergence zone at 250 yards distance from the aircraft. Within this convergence zone, all 8 bullet streams intersected, and the concentration of firepower exceeded anything that had previously been seen in single-engine fighter combat anywhere in the world. When a P-47 pilot held down the firing button for exactly 1 second, 107 half-inch projectiles left the aircraft, each travelling at 2,840 feet per second. Luftwaffe intelligence officers initially dismissed early reports about the P-47's armament as exaggerated combat claims or propaganda. 8 heavy machine guns mounted on a single-engine fighter seemed technically impossible given weight and balance constraints. German fighter doctrine had evolved over years of combat experience to emphasize efficiency above all else, mounting the minimum armament necessary to destroy enemy aircraft while conserving weight for improved performance characteristics. The Focke-Wulf 190A5, which served as the primary Luftwaffe fighter in Western Europe during the spring of 1943, carried 2 7.92mm MG-17 machine guns with 1,000 rounds each, along with 2 20mm MG 151/20 cannons mounted in the wing roots with 250 rounds per weapon. While the 20mm explosive shells were individually far more destructive than 50 caliber bullets, the limited total ammunition supply of 500 cannon rounds meant that German pilots absolutely required precise marksmanship to be effective. Over years of combat, German pilots had developed attack techniques specifically based on ammunition conservation, using short, precise bursts fired at very close range to maximize the probability of hits while minimizing ammunition expenditure. This philosophy had served German aviation well in combat against British Spitfires and Hurricanes, which typically carried 8 303 rifle-caliber machine guns, or various combinations of machine guns and cannons with similarly limited ammunition supplies. Following Blakesley's historic first victory on April 15th, encounters between P-47s and German fighters increased rapidly in frequency and intensity. On April 17th, P-47s of the 4th Fighter Group flew their first bomber escort mission, though range limitations with the early drop tank configurations forced them to turn back before reaching the bomber formation's deepest penetration points. The psychological impact on German pilots who encountered these American fighters was immediate and profound. The 8 guns created a visual effect completely unlike anything previously encountered in air combat. The P-47's standard ammunition loading sequence called for 4 armor-piercing incendiary M8 rounds, followed by 1 tracer M10 round, which meant that every 5th round glowed visibly in flight. This created the visual appearance of a continuous beam of light emanating from the American fighter rather than individual projectiles, and the effect was deeply unsettling to pilots who suddenly found themselves in front of one of these weapons platforms. By May of 1943, the Luftwaffe's Research and Testing Center at Rechlin was examining captured P-47 components that had been recovered from crashed aircraft. German engineers discovered that the Browning AN-M2 machine gun, though based on a design dating back to 1933, had been refined through continuous mass production improvements to achieve unprecedented reliability. Parts manufactured at different facilities were truly interchangeable in a way that German industry had never achieved. Any component pulled from any gun would fit perfectly in any other gun of the same type without modification or adjustment. The level of standardization was simply beyond what German manufacturing processes could accomplish. The ammunition feed system employed disintegrating link belts that ejected cleanly from the aircraft as rounds were fired, leaving no retained weight or complexity. German fighters typically used either drum magazines limited to 60 through 200 rounds depending on weapon type, or belt-fed systems that retained the metal links, adding weight that grew throughout the mission and increasing mechanical complexity. The American system's reliability was such that pilots could, if circumstances demanded it, fire their entire ammunition load in one continuous burst without experiencing stoppages or malfunctions. The sheer scale of American ammunition production stunned German analysts who examined the intelligence reports. By mid-1943, the 8th Air Force was routinely flying more than 200 P-47 sorties on a daily basis. With each aircraft carrying 2,800 rounds and pilots typically expending approximately 60% of their ammunition load during missions, this translated to roughly 336,000 rounds being fired daily. This single daily expenditure exceeded the total weekly ammunition allocation for the entire German fighter force stationed in France. The Lake City Army ammunition plant located in Missouri had reached a production capacity of 1,600,000,000 rounds annually by 1943. This single manufacturing facility outproduced Germany's entire small arms ammunition industry combined. The plant operated on a continuous basis, with 20,000 workers cycling through shifts, maintaining quality control standards so rigorous that any round varying more than 1/10,000th of an inch from specifications was rejected and scrapped. Republic Aviation's production capabilities proved equally impressive when examined in detail. The Farmingdale plant covered 765,000 square feet of manufacturing space, with additional production capacity established at facilities in Evansville, Indiana. Combined output from both facilities reached over 400 completed P-47s monthly by late 1943, while German fighter production of all types combined struggled to exceed 1,000 aircraft monthly across their entire industry. German fighter doctrine continued to emphasize lightweight, highly maneuverable aircraft optimized for air-to-air combat. The Messerschmitt Bf 109 G6 weighed 6,940 pounds when fully loaded for combat operations. The Focke-Wulf 190A5 reached 9040 pounds loaded. The P-47C weighed 13,500 pounds loaded, while the P-47D reached 14,500 pounds, figures that seemed impossibly heavy by German engineering standards. Yet the P-47's Pratt & Whitney R2800 double Wasp radial engine, producing 2,000 horsepower initially and 2,300 in later models, provided power-to-weight ratios that were actually competitive with German fighters despite the enormous weight difference. The weight that seemed so excessive to German engineers actually provided crucial advantages. It created stability as a gun platform, allowing more accurate fire, and it gave the aircraft an ability to absorb tremendous amounts of battle damage and continue flying. The General Electric turbo supercharger system alone weighed 845 pounds, nearly equal to the entire armament weight allowance on most German fighters. But this system maintained full engine power at 30,000 feet altitude, while the BMW 801 radial engine powering the FW190 lost significant power output above 20,000 feet. The shock of facing P-47 firepower forced immediate tactical changes throughout Luftwaffe fighter units in the West. Traditional attack methods that had worked effectively against British fighters became essentially suicidal when P-47s were present in the combat area. American fighters didn't need to achieve optimal firing position or close to point-blank range. Their sheer volume of fire created kill zones that German fighters simply couldn't survive crossing. Luftwaffe units began developing new tactical approaches that emphasized the FW-190's superior roll rate and turning ability at lower altitudes. But reaching those low altitudes where they held advantages required diving through the P-47's fire envelope, and many German fighters never completed that transition. American pilots progressively learned to use their altitude advantage combined with overwhelming firepower to force German fighters into unfavorable positions where the German aircraft's theoretical performance advantages couldn't be brought to bear. The contrast in ammunition philosophy created stark differences in tactical approach. German pilots entered every combat engagement knowing they had 60 to 90 seconds of firing time available before their guns ran dry. P-47 pilots had 30 through 35 seconds of continuous fire capability, but the psychological impact of that difference was immense. Germans had to conserve every round, while Americans could fire liberally without anxiety about running out of ammunition. August 17, 1943 brought the first Schweinfurt-Regensburg mission, which demonstrated both the P-47's extraordinary capabilities and its most significant limitation. Within the radius where P-47s could provide escort coverage, they absolutely devastated German interceptor formations attempting to reach the bombers. The 56th Fighter Group alone claimed 17 victories without suffering a single loss, but the P-47's combat radius extended only about 350 miles from their bases in England, and when they reached their fuel limits and had to turn back, the bombers continued onward unescorted into the teeth of German defences. German tactical controllers had evolved their procedures to exploit this predictable pattern. Luftwaffe controllers simply waited until the P-47 escorts departed before launching their heaviest attacks against the now vulnerable bomber formations. The resulting losses were catastrophic, with 60 B-17 bombers failing to return from the mission. This highlighted the desperate need for longer-range escort capability. But within the protective envelope where P-47s remained with the bombers, losses dropped effectively to zero. The contrast couldn't have been more stark. Introduction of 108-gallon drop tanks, and later 150-gallon versions, progressively extended the P-47's effective combat radius. By October of 1943, P-47s equipped with these external tanks could escort bombers to distances of 425 miles from their home bases. Each incremental extension of range meant that German fighters had to wait longer before attacking and had to fly farther from their own bases, progressively reducing the time they could spend engaging bombers before their own fuel states forced them to break off. The infrastructure supporting P-47 operations had reached industrial scales that completely defied German comprehension when intelligence officers examined captured documents. Each P-47 squadron maintained reserve stocks of 500,000 rounds of ammunition at their forward airfields. The network of airfields across England collectively stockpiled millions upon millions of rounds. Supply ships delivered ammunition in continuous streams from American factories across the Atlantic. A typical P-47 group possessed enough stockpiled ammunition for 30 days of maximum intensity operations without receiving any resupply whatsoever. German fighter units operated on 3-day reserves when they were fortunate, and often possessed significantly less. American pilots fired their guns liberally during combat, while German pilots literally counted every single round they expended. Maintenance supplies showed exactly the same disparity in availability and abundance. American depot facilities maintained complete stocks of replacement engines, entire gun sets, and all major components. When P-47s sustained battle damage, they could be essentially rebuilt from spare parts within a matter of days and returned to operational status. German units were reduced to cannibalizing damaged aircraft for parts to keep other aircraft flying, which reduced overall operational strength even when total airframe numbers remained theoretically adequate for mission requirements. October 14, 1943, remembered as Black Thursday, brought the second Schweinfurt raid and marked a significant turning point in the air war. While P-47s flew escort missions to their maximum possible range and claimed 21 German fighters destroyed, the bombers faced absolutely devastating attacks after the escorts departed upon reaching their fuel limits. German pilot combat reports from this period revealed growing concern specifically about engaging P-47 formations. The mathematics were simply irrefutable and impossible to argue against. A German fighter squadron, called a Staffel in Luftwaffe terminology, consisting of 12 aircraft might collectively possess 7,000 rounds of ammunition total across all calibers and weapon types. A single American P-47 squadron fielding 16 aircraft carried 44,800 rounds of heavy machine gun ammunition, with millions more rounds stockpiled in reserve at their airfields. The firepower advantage was further amplified by fundamental differences in training systems. American P-47 pilots arrived at combat units in Europe with over 400 flight hours of training, including 100 hours specifically devoted to aerial gunnery practice. They had fired thousands upon thousands of practice rounds at aerial targets during their training progression. German pilot training programs by late 1943 averaged just 110 total flight hours before pilots were assigned to combat units, with perhaps 20 hours devoted to gunnery training. Fuel shortages meant that many German pilots entered combat operations having actually fired their aircraft's guns only a handful of times during training. These inexperienced German pilots faced American opponents who had individually expended more ammunition during peacetime training than most German pilots would fire during their entire combat careers. Lieutenant Colonel Francis Gabreski, who would eventually become the leading P-47 ace in the European theatre with 28 confirmed victories, described the tactical reality in characteristically blunt terms. He said American pilots didn't need to be superior marksmen compared to their German counterparts. They simply needed to get their gun sight approximately on the target and hold the trigger down. The 850 caliber guns did everything else that was required. By November of 1943, P-47 groups operating from England began placing increased emphasis on ground attack missions conducted after completing their assigned bomber escort duties. The 50 caliber guns proved devastatingly effective against locomotives, road vehicles, and aircraft parked on airfields. Armor-piercing incendiary ammunition could penetrate locomotive boilers and vehicle armor plate that would stop smaller caliber weapons. A single P-47 making one firing pass could completely destroy an entire freight train through concentrated fire. The standard attack profile developed through experience involved establishing a 30-degree dive angle, opening fire at 1,000 yards distance, walking the rudder pedals back and forth to spray bullets across the target area, and pulling out of the dive at 200 yards altitude. In approximately 10 seconds of firing, a P-47 could deliver 800 through 1,000 rounds into a target area roughly 100 yards in length. German transportation networks faced systematic destruction that they had no effective means of countering. P-47s destroyed locomotives significantly faster than German industry could manufacture replacements. By December of 1943, German military units actively avoided all rail movement during daylight hours, specifically due to P-47 interdiction campaigns. The P-47's critical role in enabling the strategic bombing campaign proved absolutely crucial to eventual Allied victory. While the P-51 Mustang would eventually assume the primary long-range escort mission due to its superior range characteristics, P-47s provided the initial protective shield that allowed the bomber offensive to continue despite suffering heavy losses during the period before long-range escorts became available. By early 1944, improved P-47D variants carried 425 rounds per gun, creating a total ammunition load of 3,400 rounds. The P-47D-25 model introduced a bubble canopy providing improved visibility, along with paddle blade propellers and provisions for carrying rockets in addition to the standard 8 machine guns. These continuous improvements maintained the P-47's combat effectiveness, even as German fighters incorporated their own improvements. June 6, 1944, D-Day, provided the ultimate large-scale demonstration of what coordinated air power could achieve. P-47S flew 2,398 sorties over Normandy, claiming 84 German aircraft destroyed in aerial combat, plus an additional 89 destroyed on the ground through strafing attacks. More significantly, from a strategic perspective, they essentially paralyzed German ground movement through systematic interdiction of roads and railways. The Luftwaffe managed to fly only 319 sorties over Normandy on D-Day itself. American forces flew over 13,000 sorties. German fighters operating over Normandy collectively possessed perhaps 200,000 rounds of ammunition total. American fighters carried literally millions of rounds with effectively unlimited resupply capacity from stockpiles and production. P-47S created free fire zones across northern France, where anything that moved during daylight hours was immediately attacked and destroyed. Vehicle columns attempting to move toward the invasion beaches were reduced to burning wreckage in single strafing passes. The distinctive whistling sound produced by diving P-47s, caused by air flowing through gun ports and engine cooling ducts, became a psychological terror weapon that affected German soldiers' morale and combat effectiveness. By late 1944, German fighter production actually peaked at roughly 25,000 aircraft annually across all types. But chronic fuel shortages, catastrophic pilot losses, and overwhelming Allied numerical superiority meant that most of these newly produced aircraft never flew operational missions. Those German fighters that did manage to get into combat faced numerical odds regularly exceeding 10-1 against them. The Messerschmitt Me-262 jet fighter provided a significant speed advantage over propeller-driven aircraft, but it didn't provide firepower superiority. Its four 30mm Mk-108 cannons carried only 80 through 100 rounds per gun, totaling just 360 rounds. While these weapons were absolutely devastating against heavy bombers, the limited ammunition combined with relatively low muzzle velocity made them significantly less effective in fighter-versus-fighter engagements. The P-47N variant, specifically introduced for Pacific theater operations, carried 550 gallons of fuel internally without any external tanks. This single-seat fighter aircraft carried more fuel than German medium bombers, providing a stark demonstration of American industrial capability to build aircraft that simply defied all conventional engineering limitations and constraints. Final production numbers tell the underlying story with brutal clarity. Total P-47 production across all variants reached 15,683 aircraft. Peak monthly production exceeded 400 aircraft from combined facilities. Total Focke-Wulf 190 production across all variants from 1941 through 1945 reached approximately 20,000 aircraft. Fighter variants of the 190 totaled roughly 13,000 aircraft. Each P-47 rolling off American production lines was fully equipped with all 8 guns and adequate ammunition stocks. German fighters were increasingly delivered with reduced armament due to material shortages. By 1945, some Focke-Wulf 190 fighters operated with only 2 cannons installed instead of the standard 4, purely to conserve increasingly scarce ammunition supplies. Republic Aviation's production facilities covered over 1 million square feet of manufacturing space, operating at maximum capacity. German fighter production operated from facilities that were frequently bombed, with production increasingly dispersed to smaller facilities to reduce vulnerability, which significantly reduced manufacturing efficiency. The Lake City Army ammunition plant alone produced 1,600,000,000 rounds annually. Combined with production from other major facilities, including Frankfurt Arsenal, Des Moines Ordnance Plant, and Twin Cities Arsenal, total American production exceeded 10 billion rounds of 50 caliber ammunition during the war years. German ammunition production for all aircraft weapons of all calibers combined totaled approximately 4 billion rounds throughout the entire war. American industry produced more rounds of their single heavy machine gun caliber than Germany produced of all aircraft ammunition types combined. Quality control procedures differed dramatically between the two industrial systems. American ammunition underwent multiple inspection stages with rejection rates of 2 through 3% for rounds failing to meet exacting specifications. German production, increasingly reliant on forced labor working with substitute materials under deteriorating conditions, experienced significantly higher malfunction rates that reduced effective firepower even when ammunition was available. The United States Strategic Bombing Survey meticulously documented P-47 achievements across the European theatre. 3,916 enemy aircraft destroyed in aerial combat. 3,202 enemy aircraft destroyed on the ground through strafing attacks. Uncounted thousands of locomotives, vehicles, and other ground targets eliminated through interdiction campaigns. American training programs incorporated combat lessons and tactical developments immediately as information became available from operational units. German training programs, increasingly disrupted by fuel shortages and abbreviated by desperate necessity to get pilots into combat units quickly, produced pilots with wildly varying skill levels who then faced standardized American tactics backed by overwhelming material superiority. Beyond raw firepower numbers, P-47s incorporated numerous technological features that enhanced overall combat effectiveness. The turbo supercharger system allowed the R2800 engine to maintain full-rated power at extreme altitudes, where German engines lost significant output. The R2800's legendary reliability meant consistent performance with 400-hour intervals between major overhauls, compared to German engines requiring more frequent maintenance. The K-14 computing gun sight, introduced in late 1944, automatically computed deflection angles using gyroscopic principles. Pilots simply had to frame the target within the sight and press the trigger. German fighters continued using basic reflector sights that required pilots to manually estimate deflection angles. Electrical gun heating systems prevented weapons from freezing at high altitude. P-47 guns functioned reliably at 40,000 feet in ambient temperatures, reaching -60 degrees Fahrenheit. German fighters frequently experienced gun freezing problems above 25,000 feet, particularly with wing-mounted weapons that lacked adequate heating. American material abundance extended deeply into maintenance operations and logistics. P-47 groups maintained extensive inventories of spare parts, including complete engines, entire gun sets, and propellers. Ground crews could completely replace an engine overnight and have the aircraft ready for combat operations the following morning. Battle damage that would require weeks of repair work in German units was routinely fixed within days in American squadrons. German maintenance operations became increasingly problematic as the war progressed. Spare parts shortages meant widespread cannibalization of damaged aircraft. By late 1944, Luftwaffe average serviceability rates had dropped below 50% across fighter units. American P-47 groups routinely maintained 85% serviceability rates without extraordinary effort. American crew chiefs were extensively trained specialists with comprehensive technical education. German ground crews, increasingly depleted by conscription for infantry service, consisted more and more of hastily trained foreign workers and members of the regime's youth organization with minimal technical training. P-47S burned 100/130 grade aviation fuel, allowing operation at higher manifold pressures and increased power output. German synthetic fuel produced from coal provided inconsistent octane ratings that reduced both performance and reliability. By late 1944, German fighters received fuel allocations of 30 through 50 gallons per sortie when fuel was available at all. P-47S routinely carried 370 gallons internally, plus whatever external tanks were fitted. American pilots flew multiple missions daily without fuel concerns, while German pilots remained grounded by fuel shortages even when aircraft were technically available. German pilots understood that aggressive maneuvering consumed precious fuel needed for the return flight to base. American pilots flew without fuel anxiety, enabling aggressive tactics that Germans couldn't match due to resource constraints. The P-47's design philosophy of standardized mass production meant faster manufacturing at lower unit costs. This fundamental approach extended throughout the entire supply chain supporting operations. The same .50 caliber ammunition fired by P-47 fighters was also used by heavy bombers, ground vehicles, and naval vessels. This universal standardization simplified logistics enormously while achieving economies of scale that would have been impossible with diverse calibers requiring separate production and supply chains. German attempts to match American firepower levels proved completely futile given their resource constraints. The FW-190A8 variant, introduced in February 1944, could mount additional cannons in underwing pods to increase firepower, but the added weight and aerodynamic drag severely degraded flight performance, making these heavily armed variants vulnerable to escort fighters. The Sturmblock variant, specifically optimized for destroying heavy bombers with extensive armor protection and 30mm cannons, was essentially helpless when engaged by escort fighters and suffered catastrophic losses. The fundamental problem facing Germany was simple industrial capacity. Germany could not simultaneously fight a multi-front war spanning from the Atlantic to deep inside Russia, while also matching American industrial production levels. Every attempt to do so only accelerated the exhaustion of already limited resources. Beyond the physical destruction they inflicted, P-47s achieved a crucial psychological victory over German forces. The distinctive whistling sound of diving P-47s became such an effective terror weapon that German soldiers developed persistent anxiety about aircraft attacks, diving for cover at any aircraft sound, regardless of whether actual attacks were imminent. American pilots clearly understood their enormous psychological advantage and exploited it ruthlessly. They flew with supreme confidence derived from unlimited material resources supporting their operations. German pilots flew with increasing desperation born from chronic scarcity of everything needed to fight effectively. This fundamental mental state difference affected tactical decision-making at every level, with German pilots increasingly avoiding combat engagements unless absolutely necessary for mission completion. The P-47 achieved an overall kill-to-loss ratio of 4.6 to 1 across more than 746,000 combat sorties flown in the European theatre. Approximately 3,000 P-47s were lost to all causes, including combat, accidents, and mechanical failures. This represented less than half of 1% loss rate per sortie flown. German fighter units were suffering 50% monthly casualty rates by late 1944, a completely unsustainable attrition rate. The 56th Fighter Group, flying exclusively P-47 Thunderbolts throughout the entire war without transitioning to other aircraft types, became the top-scoring American fighter group in Europe with 674 confirmed aerial victories. This conclusively demonstrated that the P-47's supposed limitations could be completely overcome through superior firepower, exceptional durability, and well-trained pilots employing proper tactics. The P-47's 850 caliber machine guns represented far more than simple firepower statistics. They embodied the triumph of American industrial philosophy over traditional European approaches. Each individual gun required precision manufacturing processes and complex supply chains to produce and maintain. That America could mount 8 guns per fighter aircraft with sufficient ammunition to sustain combat operations demonstrated industrial supremacy that transcended purely military calculations and entered the realm of economic warfare. Military historians universally recognize P-47 firepower as decisive in achieving complete air superiority over Western Europe. The ability to deliver absolutely overwhelming firepower at extended ranges from heavily defended bases broke the Luftwaffe's defensive capability beyond any hope of recovery. Once air superiority was conclusively achieved, ultimate Allied victory became essentially inevitable regardless of ground operations. The P-47's influence extended far beyond World War II's immediate conclusion. It established fundamental principles that continue dominating modern air combat doctrine to this day. Achieving firepower superiority through sheer volume of fire, standardization enabling true mass production, industrial capacity ultimately determining military capability in extended conflicts, modern fighters mounting rotary cannons capable of firing 6,000 rounds per minute are direct philosophical descendants of the P-47's design approach. Even precision-guided munitions represent evolution rather than rejection of the underlying firepower principle, simply another manifestation of overwhelming force delivered through industrial and technological superiority. When West Germany rebuilt its air force during the 1950s, it adopted American equipment, American tactics, and American doctrine wholesale. German pilots trained on American aircraft, fired American ammunition, and absorbed American military philosophy completely. The student had learned comprehensively from the master who had defeated them so thoroughly. While aggregate statistics tell the broad strategic story effectively, individual accounts reveal the crucial human dimension underlying the numbers. Colonel Robert Johnson of the 56th Fighter Group survived a ferocious attack on June 26, 1943, that put over 200 bullet and cannon shell holes in his P-47. The aircraft absorbed damage levels that would have completely destroyed any German fighter design, yet still flew Johnson home safely with flight controls damaged and the canopy shattered. Colonel Hubert Zemke, commanding the 56th Fighter Group, personally developed innovative tactics specifically designed to maximize the P-47's inherent advantages while minimizing its limitations. His famous Zemke fan formation spread squadrons wide across the sky, creating overlapping fields of fire that German fighters simply couldn't penetrate without suffering catastrophic losses. Under his aggressive leadership, the 56th achieved truly remarkable success flying exclusively P-47s when many other groups transitioned to longer-ranged P-51 Mustangs. German pilot Heinz Knoke, author of the memoir I Flew for the Führer, described the experience of facing P-47 formations as confronting what appeared to be solid streams of tracer fire rather than individual bullets, making any approach to bomber formations through the escort screen effectively impossible without accepting near-certain death. His detailed memoir provides invaluable German perspective on experiencing American firepower superiority from the receiving end. Behind all the impressive statistics were millions of American workers who formed the arsenal of democracy's industrial foundation. At Republic Aviation's Farmingdale plant, women comprised 40% of the total workforce by 1943. These workers built P-47s to precision standards, exceeding peacetime manufacturing requirements, while simultaneously maintaining unprecedented production rates that seemed impossible by traditional standards. The Lake City ammunition plant operated continuously around the clock, with workers producing billions of rounds in carefully climate-controlled facilities designed to maintain consistent manufacturing conditions. Quality control inspectors, predominantly women, meticulously rejected any rounds failing to meet exact specifications. Their unwavering dedication ensured that American pilots never experienced the ammunition malfunctions and failures that increasingly plagued German fighter operations. American workers earned genuinely good wages by contemporary standards, lived comfortably, and took authentic pride in their contribution to the war effort. German production became increasingly dependent on forced labor working under steadily deteriorating conditions, resulting in widespread sabotage and continuously declining quality that couldn't be addressed through supervision alone. The entire P-47 program cost approximately $1.3 billion in 1940s currency values. This represented a truly massive investment in a single weapon system by any historical standard. Yet American industrial capacity made this level of investment completely affordable, while simultaneously producing thousands of other aircraft types, tens of thousands of tanks, and hundreds of warships. American mass production techniques reduced unit costs continuously throughout the production run. Early P-47 fighters cost over $100,000 each to manufacture. By 1945, unit costs had dropped to $83,000, despite aircraft incorporating significantly increased capabilities and improvements. German fighter costs increased steadily throughout the war as production dispersal and chronic material shortages systematically reduced manufacturing efficiency. Detailed post-war analysis revealed the enormous gulf separating American and German production methodologies. American factories employed specialized machine tools, assembly line production techniques, and statistical quality control processes. German production largely retained traditional craft methods that were fundamentally unsuitable for true mass production at the scales required. The Browning M2 machine gun's basic design actively facilitated mass production through simple, robust components that could be manufactured by semi-skilled workers using largely automated machinery. German weapons generally required skilled craftsmen using traditional methods with significant hand-fitting of components. This fundamental philosophical difference meant that America could expand production almost exponentially, while Germany struggled to maintain existing output levels. The P-47's 8 synchronized machine guns represented a complete synthesis of multiple American advantages working in concert. Industrial capacity providing the essential foundation. Technological innovation enabling tactical effectiveness. Logistical excellence delivering materials where needed. Comprehensive training ensuring pilots could fully exploit available advantages. No single element proved individually decisive in isolation. Their complete combination proved utterly overwhelming to opponents lacking equivalent integration. Industrial capacity provided the indispensable foundation through ability to produce fighters, guns, and ammunition in previously unimaginable quantities. Technology enabled tactical effectiveness through turbo supercharging, reliable engines, and precision manufacturing. Logistics delivered required materials exactly where needed when needed. Training programs ensured pilots could effectively exploit all available advantages. Germany certainly possessed numerous excellent pilots with superior individual skills. They had innovative technology in many areas. German tactical sophistication remained high throughout the war. But without the fundamental industrial foundation required to support these advantages adequately, they ultimately proved insufficient against American material superiority. The Luftwaffe was defeated not primarily by superior individual tactics or pilot skill, but by completely overwhelming material superiority, symbolized most visibly by 8 heavy machine guns firing continuously with apparently unlimited ammunition reserves. German pilots facing P-47 Thunderbolts in combat learned harsh, unforgiving lessons about modern industrialized warfare's true nature. Their Focke-Wulf 190s, which were genuinely excellent fighter aircraft by any traditional evaluation standards, were simply overwhelmed by American firepower delivered through systematic industrial production, at scales they couldn't begin to match. 8 50-caliber machine guns, supplied with effectively unlimited ammunition, represented entirely new warfare paradigms that rendered traditional approaches obsolete. The transformation from initial confidence through shock and disbelief to final acceptance mirrors Germany's larger World War II experience across all theatres. Initial tactical superiority based on innovation, training, and hard-won combat experience crumbled steadily against American mass production and material abundance that couldn't be overcome through skill alone. The P-47, initially dismissed by many as far too heavy to be an effective fighter, conclusively proved that overwhelming industrial might could overcome apparent tactical disadvantages. German pilots weren't merely stunned by 8 guns firing in perfect unison. They were fundamentally shocked by what those 8 guns represented on a deeper level. A continental nation producing unlimited weapons, unlimited ammunition, and unlimited aircraft that simply could not be stopped through conventional military means. The Focke-Wulf 190 might well have been the superior aircraft by traditional evaluation criteria emphasizing maneuverability and efficiency. But traditional criteria had become fundamentally obsolete in an era of total industrial warfare. The P-47's 850 caliber machine guns rewrote all existing air combat rules through the application of overwhelming industrial power to tactical problems. The enduring legacy persists in every modern fighter design, emphasizing firepower over finesse, every massive munitions expenditure in contemporary conflicts, every industrial approach to military challenges. All trace their philosophical lineage directly to that transformative moment when German pilots first encountered 8 perfectly synchronized Browning machine guns concentrated on a single airframe and realized immediately that their entire understanding of air combat had become completely obsolete overnight. The P-47 Thunderbolt didn't merely outgun the Focke-Wulf 190 in direct combat. It comprehensively outproduced, outsupplied, and ultimately outthought the entire German aviation philosophy through overwhelming firepower delivered by industrial democracy operating at maximum capacity. Those 8 guns weren't simply weapons mounted on an aircraft. They served as messengers delivering news of American industrial might that couldn't be ignored or rationalized away. Every sustained burst fired in combat demonstrated production capabilities that the regime in Berlin could never hope to match, regardless of how many resources were diverted from other priorities. The thunderous combined roar of 8 synchronized Browning machine guns firing simultaneously announced the defeat of German military ambitions more clearly than any diplomatic communication ever could.